Hello, smart mathematicians. In this lesson, we're going to look at the line from center perpendicular to chord, and then we're going to prove this theorem. Okay, right, let's try to do that. Right, so what does this theorem say? It says that the line drawn from the center of a circle, okay, the line drawn from where? From the center of a circle, that's this line there. And then when this line is perpendicular to the chord, you see that? Because the chord is AB. AB is our chord here. So the line drawn from the center of a circle, perpendicular to the chord, and then what does it do? It is, or we say it bisects the chord. When you're saying bisecting the chord means that it divides the chord into two equal parts. So meaning that here, if this point is M there, it means AM is equal to MB, or MA is equal to MB. You see that? So that's what the theorem says. A line drawn from the center of a circle perpendicular to the chord bisects the chord. Okay? Right. So when you are proving this theorem, I want us to remember congruency. We can use congruency to prove that the sides of a triangle are equal. Remember, let's say we have two triangles that are congruent. Let's say you say triangle ABC. I'm just giving you these vertices, like we don't have those vertices there. Triangle ABC is congruent to triangle DEF. Right. From this congruence, you can conclude and say AB is equal to DE. Do you know that? And then BC is equal to EF, then AC is equal to DF. So to prove this theorem, we use what? Congruency. And then do you remember the conditions for congruency? We have side, 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 angle, side. Remember this one, you don't have side, side, angle or angle, side, side. Remember, the angle must be included. And then we have angle, angle, side, and then the last one, right angle, hypotenuse, side. Those are the four conditions for congruency. Right, now let's go to the proof. We are required to prove that AM is equal to MP. The other main thing that we need to remember when we're proving theorems is construction. So now, since we're going to use congruency, so it means we have to construct what? We have to construct triangles. So construct what? Construct OA and OB. Construct OA and OB, which are radii, and radii are equal. So now we have our two triangles, which is triangle AMO and triangle BMO. So in triangle AMO and triangle BMO. Right, what can we say? We have this common side OM. So we have OM is equal to OM, which is a common side. Common side. If you look at these two triangles, okay, common side. And then what else do we have? These sides are equal, OM, OA and OB. OA and OB, they are equal. So we can say OA. Right, I'll start with triangle AMO. This OA is equal to OB. What's the reason? Radii. They are radii. Radii are equal. And then remember we told that the line from the center perpendicular to the chord. So it means we're given that M2 and M1 are what? Are 90 degrees. So for triangle AMO, that is M1. So we say M1, angle M1 is equal to angle M2, and both of them are equal to 90 degrees. And then we have what? We're given this. We're given a line drawn from the center perpendicular to the chord. So we're given that. So can we conclude and say these two triangles are congruent? Yes, we can say therefore triangle AMO is congruent to triangle what? We're moving from the point towards the 90-degree angle, so it means BM, then common side. From the circumference to the center, then common side. Circumference to the center, common side. So it's going to be triangle BMO. And then the reason, if you check, these are right angled triangles, and then OA and OB are the hypotenuses. So now we have right angle, and then hypotenuse, then side, the common side, this one. Right angle, hypotenuse, then side, this common side. Okay, see that? Therefore, these two triangles are congruent. And then from this, we can say, therefore, AM is equal to BM. So therefore, AM is equal to BM or MP. Then the reason here, MP, the reason we say congruency, or say triangle AM or is congruent to triangle BMO. Done. We've proved that the line drawn from the center perpendicular to the chord will bisect the chord. Right, and then now we can see that these two AM is equal to MP. Right, the reason we say line from center perpendicular to chord. Remember this, you can write this one down. This is the reason we write, okay? Right. So we're going to meet in our next lesson. Goodbye.